An arithmetic progression is a sequence of numbers such that the difference between the consecutive terms is constant. Recall that the difference found by subtracting a term in a sequence from its immediate succeeding term is called common difference and is denoted by the letter D. Identify the first term and the common difference for the given arithmetic progression. Also, state the next three terms of the given AP. Identify the first term and the common difference for the given arithmetic progression. Also, state the next four terms of the given AP. Now that we've revised arithmetic progression or AP and common difference, let's move on to learn about the general form of an AP and the nth term of an AP. An overhead tank contains 100 liters of water. Every minute, 70 liters of water get added to the tank. How many liters of water will the tank hold after 60 minutes? Let's find out. Consider the initial amount of water in the tank as A, and the amount of water getting added every minute as D. The amount of water in the tank after 1 minute will be the sum of the initial amount of water A and the amount of water added every minute, which is denoted by D. Thus, after 1 minute, the tank will contain 170 liters of water. Now, after 2 minutes, the tank will contain the initial amount, that is, 100 liters added to 2 times 70 liters of water. Thus, after 2 minutes, the tank will contain 240 liters of water. Similarly, to find the amount of water after 3 minutes, we find the sum of 100 liters and 3 times 70 liters of water. So, the amount of water after 3 minutes will be 310 liters. In this way, we can find the amount of water the tank will hold after 4 minutes and so on. Observe that these numbers are in an arithmetic sequence because the difference between any two successive numbers is 70. In other words, each term except the first is the sum of the immediate preceding term and the common difference. This form is known as the general form of an AP. How would you represent the amount of water in the tank after 60 minutes? The amount of water after 60 minutes is represented as 61st term. In general, we represent the amount of water for n minutes as n plus 1th term. We can say that A1 is the first term, A2 is the second term, and so on. So the 61st term in an AP is A61. In general, the term AN is the nth term of an arithmetic progression. Do you see any pattern in this? Observe closely the number of the term and the coefficient of D. Can you see a relation between them? The coefficient of D is equal to 1 less than the number of the term. For example, for the first term, A1, the coefficient of D is 0. In the second term, A2, the coefficient of D is 1. In the third term, A3, the coefficient of D is 2, and so on. Thus, the nth term of an arithmetic progression is equal to A plus n minus 1 times D. Let's go back to our previous problem to find the amount of water in the tank after 60 minutes. Thus, 61st term of this arithmetic progression is equal to A added to 60 times D. We then put in the values of A, which is 100, and D, which is 70, and simplify. Thus, we find the amount of water in the tank after 60 minutes. Find the 15th term of the given arithmetic progression. First, we write the value of A and find the common difference of the given AP. We know the formula to find the nth term of an arithmetic progression. As we have to find the 15th term in the given AP, n equals 15 in this example. We substitute the values for a, n, and d and simplify. Hence, we find the 15th term of the given AP. Which term of the given arithmetic progression is negative 41? First, we write the value of a and find the common difference of the given AP. Let's represent negative 41 as a, n. Hence, we need to determine the value of n to know the term of negative 41. We then put in the values and simplify. Thus, we find the value of n. The sum of the interior angles of a three-sided polygon, a four-sided polygon, and a five-sided polygon are given. Find the sum of the interior angles of a polygon with 15 sides. The difference between any two consecutive terms is 180. So, the terms are in arithmetic progression where a and the common difference is 180. To find the sum of the interior angles of a polygon with 15 sides, we need to find the 15th term of this AP. We know that the nth term of the arithmetic progression is equal to the sum of a and n minus 1 times d. We substitute the values of a, n, and d in the formula. Therefore, we find the 15th term of the arithmetic progression, which is equal to the sum of the interior angles of a 15-sided polygon. A car has covered a distance of 40 kilometers in the first hour. Thereafter, the car covers a constant distance of 50 kilometers every hour. After how many hours will the car cover a distance of 540 kilometers? As the car is covering a distance of 50 kilometers every hour, the common difference of the arithmetic progression is 50. The value of a40 as the distance covered by the car in the first hour is given as 40. Let's consider an equals 540. The value of n will tell us the position of 540 in the AP. Hence, determining the value of n will tell us the number of hours the car takes to cover a distance of 540 kilometers. We apply the formula for finding the nth term of AP. Then we substitute the values of a and d in the formula and find the value of n, which is the number of hours the car will cover a distance of 540 kilometers. Determine the AP that has 7th term as 4 and 15th term as 36. Using the formula for nth term of the arithmetic progression, we write 7th term and 15th term as shown. Thus, we get two linear equations in two variables as shown. Next, we find the value of d by subtracting the two linear equations. We substitute the value of d in one of the equations to find the value of a. Now, we use the general form of AP and substitute the values a and d to write the required arithmetic progression. Check whether 109 and 25 are the terms of the given arithmetic progression. We write the value of a and find the common difference of the given AP. Next, to find whether 109 is a term of the given arithmetic progression, we consider 109 as an. If the value of n is an integer, then we can say that 109 is a term of the given AP. Otherwise, we say that 109 is not a term of the given AP. Next, we substitute the values of a and d and then simplify to find the value of n. Since the value of n is an integer, 109 is a term of the given arithmetic progression. Note that 109 is the 13th term of the given AP. Similarly, we consider 25 as an and find the value of n. Since the value of n is not an integer, 25 is not a term of the given AP. Find the number of terms in the given arithmetic progression. We write the value of a and find the common difference of the given AP. Next, let the last term be an. Using the formula to find the nth term, we can find the value of n. Note that 107 is the last term in the given AP. So, determining the value of n, we tell us the number of terms in the given AP. We substitute the values of a and d and simplify. Hence, we find the value of n. 107 is the 14th term in the given AP, and it is also the last term. Thus, the number of terms in the given AP is 14. How many two-digit numbers are divisible by 4? Let's write the first few double-digit numbers that are divisible by 4. Notice that the list of numbers is an arithmetic progression with a common difference 4 and 12 as the first term. Next, the greatest two-digit number that is divisible by 4 is 96. Therefore, the last term of the arithmetic progression is 96. Now, let this last term be n. The value of n will tell us what term 96 is in the given AP. We know that 96 is the last term, and so the value of n will give the number of terms in the given arithmetic progression. We substitute the values of a and d, and hence we find the value of n, which is equal to the number of terms in the given arithmetic progression. Thus, we find the number of two-digit numbers that are divisible by 4. Find the 50th term of an arithmetic progression if the 11th term is -1 and 26th term is 44. The 11th term and 26th term of the arithmetic progression are given. Hence, we get two equations in two variables as shown. Next, we solve the two linear equations and find the values of a and d. We can now apply the formula for finding the nth term of an AP. We substitute the values for a, n, and d and simplify. Thus, we find the 50th term of the AP.